Science advances not only by what we discover, but by what we fail to explain. Every so often, nature presents us with an object that does not neatly fit into our existing categories. When that happens, scientists have two options. Either stretch reality to protect their assumptions or allow the data to challenge their worldview. History shows that progress only occurs when we choose the latter. The newly released images of 3I Atlas represent one of those moments. At first glance, 3I Atlas appeared to be yet another interstellar object, a visitor passing briefly through our solar system, much like Oumuamua in 2017 or Borisov in 2019. Interstellar objects are no longer surprising. Based on current estimates, millions of such objects likely drift through our galaxy at any given time. But science is not about first glances. It is about careful measurement, comparative analysis, and pattern recognition. And when astronomers began analyzing the latest 3I Atlas images, taken at higher resolution across multiple wavelengths, something unexpected emerged. Not something sensational, not something conclusive, but something uncomfortable. The object's brightness profile, trajectory stability, and lack of a conventional cometary coma place it in a statistical minority, a region of parameter space that is not easily explained by known natural populations. This does not mean 3I Atlas is alien technology, but it also does not mean we should rush to dismiss the anomaly. The responsible scientific question is not, is this extraterrestrial? The correct question is, does the simplest natural explanation adequately explain the data? And if it does not, then, by definition, we must consider alternatives, however unfamiliar they may feel. This is not speculation. This is how science works. When Galileo pointed his telescope at Jupiter and saw moons orbiting another planet, the data contradicted centuries of belief. When astronomers first observed pulsars, they briefly labeled them LGM, little green men, not because they believed in aliens, but because the signal was so precise that it defied known astrophysics at the time. Eventually, a natural explanation emerged. But the key is this: the explanation came after the anomaly was taken seriously, not before. In the case of 3I Atlas, what makes the object noteworthy is not a single property, but a convergence of oddities. Its interstellar velocity is unusually well aligned with the local standard of rest. Its reflectivity suggests a surface composition inconsistent with typical icy bodies. Its light curve variability hints at a geometry that is difficult to reconcile with rubble pile asteroids. And most intriguingly, it shows no detectable outgassing, even when exposed to solar heating levels that would normally activate volatile materials. In science, when multiple low-probability features cluster together, we do not ignore them. We ask why. One explanation is selection bias, that we are overinterpreting incomplete data. That is always a possibility, and it must be addressed rigorously. Another explanation is that our models of interstellar debris are incomplete, which is also likely. But a third explanation, one that many scientists are emotionally uncomfortable with, is that some fraction of interstellar objects may not be purely natural. Not most, not many, but some. The universe is nearly 14 billion years old. Our technological civilization has existed for roughly 100 years. Statistically speaking, it would be extraordinary if intelligence emerged only once, here, now, in this tiny window of cosmic time. The Copernican principle suggests we are not special observers, nor should we expect our circumstances to be unique. If technological civilizations arise elsewhere, even rarely, then their artifacts could outlast their creators by millions or billions of years. Just as we have launched spacecraft beyond Earth, Voyager, Pioneer, New Horizons, other civilizations may have done the same long before we existed. Some of those objects could still be drifting through interstellar space, and occasionally one might pass through our solar system. This idea is not science fiction. It is a logical extension of astrophysics, probability theory, and technological evolution. The question is not whether this possibility is comfortable, it is whether it is plausible. The images of 3I Atlas do not provide an answer, but they do provide a reason to ask better questions. And science advances by asking questions that others are reluctant to ask, as long as we are willing to accept whatever answers the data ultimately give us. To understand why 3I Atlas deserves serious attention, we must first strip away speculation and focus exclusively on what is measurable. Astronomy is an observational science. We cannot conduct laboratory experiments on interstellar objects. All we have are photons, light collected across distance and time, and the models we use to interpret them. The first critical observation concerns trajectory. 3I Atlas entered the solar system on a hyperbolic path, confirming that it is not gravitationally bound to the Sun. This alone is unremarkable. Interstellar objects are expected to follow such trajectories. What is unusual is the object's velocity vector. Most interstellar objects should exhibit random velocities relative to the Sun, reflecting the chaotic gravitational interactions of the galaxy. 3I Atlas, however, appears to move unusually close to the local standard of rest, the average motion of stars in our neighborhood. In simple terms, it is not rushing past us. It is almost co-moving with the Sun. From a statistical standpoint, this is unlikely, but not impossible. However, when improbable features accumulate, scientists pay attention. The second anomaly lies in photometric behavior. As 3I Atlas approaches the Sun, we expect solar heating to trigger sublimation, the release of gas and dust, producing a visible coma or tail if the object is cometary. But despite sensitive observations, no such features have been detected. This absence cannot be easily explained by observational limits alone. If volatile materials were present in expected quantities, we would see evidence of them. One might argue that the object is depleted, an old exhausted comet. That is plausible. But interstellar travel exposes objects to extreme conditions that tend to erode fragile volatiles over time, making long-lived icy bodies less common than rocky or metallic ones. Yet the surface reflectivity of 3I Atlas does not neatly match known asteroid classes either. Its albedo suggests a surface that is neither dark, like carbonaceous asteroids, nor bright like icy bodies. Instead, it sits in an intermediate regime that raises questions about composition and structure. Another important observation concerns non-gravitational acceleration. In Oumuamua's case, slight deviations from predicted motion were detected, initially attributed to outgassing, though no gas was observed. Alternative explanations included radiation pressure acting on a thin, possibly sheet-like structure. For 3I Atlas, the data is still preliminary, but early modeling suggests that if non-gravitational forces are present, they are subtle and not easily explained by standard mechanisms. At this stage, we must be disciplined. There is no direct evidence that 3I Atlas is artificial, but there is equally no compelling evidence that our current natural models fully explain it. This is the critical scientific tension. When confronted with anomalies, the worst response is dismissal. The second worst response is sensationalism. The correct response is open-minded rigor. We must ask, what population of objects could produce these properties naturally? How common should such objects be? And why are we encountering one now? The answers may reshape our understanding of interstellar matter, or something more profound. When scientists encounter an anomaly, the instinctive reaction is often defensive. This is understandable. Entire careers are built on established frameworks, and anomalies threaten intellectual stability. But progress has never favored comfort. The correct response to 3I Atlas is not belief and not denial, but structured consideration of competing hypotheses. Let us examine them carefully. The most conservative explanation is that 3I Atlas belongs to a previously uncharacterized population of interstellar debris. This is plausible. Our models of interstellar matter are extrapolated from a sample size of 2 prior objects, Oumuamua and Borisov. That is not a statistically meaningful foundation. It would be surprising if early detections were representative of the entire population. In this scenario, 3I Atlas could be a devolatilized comet nucleus stripped of ices over billions of years, a fragment from a differentiated planetary body, or an object whose surface chemistry evolved under radiation exposure in interstellar space. None of these explanations violate known physics. However, they do introduce new assumptions that such objects are common enough to detect now, that their properties differ substantially from solar system analogs, that their apparent anomalies align coincidentally. Science allows such assumptions, but tracks them carefully. Another explanation is that our instruments are biased toward detecting objects with certain properties. This is an important point. We do not detect interstellar objects randomly. We detect those that are bright enough, moving at detectable velocities, passing sufficiently close to Earth. This means that our sample is inherently skewed. But bias cuts both ways. If observational bias were the sole explanation, we would expect anomalies to be distributed randomly across parameters. Instead, we see clustering, unusual shape, unusual motion, unusual reflectivity. Bias alone does not easily explain correlation. Now we arrive at the most controversial possibility, and the most emotionally charged. Could 3I Atlas be an artificial object? Let us be precise. This does not mean a spacecraft under control, a probe observing Earth evidence of contact or intent. The more reasonable concept is something far more mundane and far more likely to persist. Technological debris. Every technological civilization produces waste. We already do. Defunct satellites, spent rocket stages, abandoned probes. Some of these objects will outlast our civilization. On cosmic timescales, artifacts survive longer than intentions. If even a tiny fraction of extraterrestrial civilizations launched interstellar technology, deliberately or accidentally, their remnants could wander the galaxy for billions of years. Such objects would have unusual geometries, possess non-natural surface properties, exhibit atypical interactions with radiation. Importantly, they would not emit signals. They would not announce themselves. They would simply exist. This hypothesis is extraordinary, but not forbidden by physics, and it makes a testable prediction. Artificial objects should occupy regions of parameter space that natural processes rarely populate. That is exactly where 3I Atlas appears to sit. This phrase is often misused. Extraordinary claims require proportionate evidence, not impossible standards. If we demand certainty before exploration, we guarantee ignorance. When archaeologists uncover an object of unknown origin, they do not discard it because they cannot immediately explain it. They catalog it, analyze it, and compare it. Astronomy deserves the same intellectual humility. The hypothesis of artificial origin does not replace natural explanations, it competes with them. Whichever hypothesis best explains the data with the fewest assumptions will ultimately prevail. That is science. The debate surrounding 3I Atlas cannot be resolved by rhetoric. Only data can do that. We must prioritize high-resolution spectroscopy, precise acceleration measurements, polarimetric analysis, long-term monitoring. We must also invest in early detection systems capable of intercepting future interstellar objects. Imagine the scientific value of rendezvousing with such an object, natural or artificial, and examining it directly. The discovery alone would reshape planetary science. And if the object were artificial, then humanity's place in the universe would change forever. Not because of fear, but because of perspective. There is a quiet irony in our search for meaning in the universe. For centuries, humans believed the Earth was the center of everything. Then we learned it was not. We believed the sun was unique. Then we learned it was one of hundreds of billions. We believed life might be rare. Then we discovered it thrives in the harshest conditions imaginable. Each time, the universe humbled us and expanded us. The question posed by 3I Atlas is not whether aliens exist. The deeper question is whether we are mature enough to ask the question honestly. Science is not threatened by uncertainty. It is powered by it. Dismissing anomalies does not make us rational. It makes us complacent. Believing without evidence does not make us visionary. It makes us careless. The path forward lies between these extremes. If 3I Atlas turns out to be natural, we will have learned something profound about the diversity of interstellar matter. If it turns out to be artificial, we will have learned something even more profound, not about them, but about ourselves. That intelligence is not unique. That technology is not eternal. That civilizations leave traces, even when they are gone. Such a realization would not diminish humanity. It would contextualize us. And context is the foundation of wisdom. One day, long after our cities fade and our languages vanish, something we built may still be drifting between the stars, silent, inert, but real. If another civilization encounters it, they will ask the same questions we are asking now. Not, who built this, but, what kind of beings leave things behind, and what became of them? 3. Atlas reminds us that the universe is not obliged to fit our expectations. It invites us to grow, intellectually, scientifically, and philosophically. And that, more than any answer, is what makes it worth studying.